The purpose of this example is to calculate the gravitational force between the Earth and an apple. According to Newton's law of universal gravitation, the Earth is pulling on the apple with the force as shown here. In the same way, the apple is pulling on the Earth. This force is shown here. Our goal is the force, which can be represented as a question mark inside a box. Here's Newton's law of universal gravitation. G is a constant. m1 becomes mass of the Earth. m2 becomes mass of the apple. And the radius is the radius of the Earth, because the distance from the apple to the Earth's surface is going to be very small compared to this number. Assume the mass of the apple is 150 grams. Then use Google to look up data. We can find the value of the gravitational constant. The mass of the Earth is given here. The radius of the Earth is given here. And now we have all the information we need to plug numbers into this equation. Before doing calculations on this equation, I'm going to rearrange the equation as shown here. And the reason why is that the constant g, the mass of the Earth, and the radius of the Earth are all constants. So I can group these constants together and call this a new constant, which I'll identify with the lowercase letter g. Now I'm ready for calculations. Step 1 is to calculate the constant g. G was equal to the constant big G times the mass of the Earth, the radius of the Earth squared. So I put numbers in. Kilograms cancels the squared term. The meter squared cancels. The result is 9.798 newtons per kilogram. And if I use the definition of a newton, I can also write this as 9.798 meters per second squared. And the accepted value of this number, if I use more accurate values of the mass of the Earth, the radius of the Earth, etc., is 9.807 meters per second squared. So now I can calculate the gravitational force between the Earth and an apple. Here's the equation I'm going to use. I substitute in numbers, and the answer is 1.47 newtons, which is about 1/3 of a pound force. Now I've zoomed out so you can see the whole calculation. The point of this example is that anytime you do a problem like this, the gravitational force between the Earth and any object, this group of terms right here, let's zoom in on that, this group of terms right here will always end up being a constant. Let me zoom back out so again you can see the whole example. Thank you very much for watching this video. I hope it has been very useful for you. See you next time.